We've got one more lesson in this unit, okay? Couple of reminders. So we did our homework check. We've done 2 CFUs, okay? I recommend that you hold on to those CFUs. I'm going to come get the grades eventually, but I would keep those and I would use those as a study tool for your next test. I will get the answer keys up on Canvas like after review day, so that way you can have those if you missed anything. But I think those are really good questions to know how to do. And then next class, we're going to do one more check for understanding. Again, they're short, just like 2 questions over writing. I'm going to check the rest of the homework and anything that you're missing. And then next class will be review day. And we'll spend time working on the review, but you should be able to leave next class with a test review, 3 CFUs, homework packet that's completed. You got everything you need to do well in this next test. Just a reminder, I went over this last time, I'm pretty sure. Did I? Yeah, I saw it. Okay, yeah. We are reserving this last week, the last 2 days, which is kind of weird because it's a Monday and it's a Thursday for A-Day. With this random, remember that Wednesday is a B-Day, so I won't see y'all then. But if you are missing the test for any reason, you've got this day to make up the Unit 10 test. Please don't. We've also got this full day of class for Unit 9 retest, Unit 10 retest. Just know, if you're not going to be there, this doesn't work for you, you have to communicate with me, okay? Otherwise, I'm going to assume if you plan to take this stuff, then you'll be there. Does that make sense? You'll be in class. Yes. So that means if you don't have to make up a test or you don't have to retest something, then you get a chill week and you can do what you need to do in class, staying on task and quiet and not. Next week, I do have tutorials. Obviously, you have a test next week. That should be first priority. But if you still haven't come in and gone over stuff like for Unit 9 in your retesting, we need to get that done next week as well. So, but that's on y'all. I can't keep up with everyone's schedule. Mine is on Canvas. Show up when you need to, but be ready for your stuff, okay? I will say I'm really tired of grading retests when, like, over 60% of people are not doing better. It's wasting my time. It's wasting your time. If you aim to do better on a retest, then you need to come in and do something. Come in and review your test at minimum, okay? It doesn't mean just, like, show up breathing and you're going to do better. It's not going to work that way, okay? But because of the changes, you do, I should have this Unit 10 test. That should be graded before Monday the 4th, so you can have an idea if you want to do it. Yes?
So if I miss Thursday next week, then I can take it Monday.
In class on Monday, as long as you're here. Yeah. So, I mean, we're going to have to stay, like, these weeks because people could be retesting or testing. Like, we're going to have to stay, under control. But if you're not doing that, then just have something else to do. Okay? And we'll pick back up after spring break. But anyways, that's what we're doing here. Here's the last little bit. And the Unit 10 test is 2 grades. Identifying attributes and then graphing and writing. So we just did a CFU on graphing. Today we're going to learn how to write. This is really going to put everything together. Okay? So this is a good lesson. Hey, last warning. So we're writing from words and from graphs. It seems like a lot of problems, but a lot of times these are really quick. And again, it just kind of reinforces all the stuff we've been doing. So we had 2 different forms. We had transformational form, which is this one. Transformation form, which is, I honestly don't really do the one with A factored out, but that's your transformation form right there. And then this one is your rational form. What's the difference between the 2? Transformation form has a number on the outside, okay? Also, the A value in transformation form, the numerator of the fraction, will only be a number. It shouldn't be like an actual polynomial. Rational form are going to be more complicated looking, but they are just one fraction. And remember, make sure you know what you can see from those. There's 2 things that you can see in transformation form, and that's the asymptote. So I would write this down, and I would know this. What is your horizontal asymptote in transformation form? No, it's not A.
Oh, it's D.
Y equals D. No sign change there. What is your vertical asymptote in transformation form?
C.
X equals C, but that one is the flip. Okay? Rational form, again, they do the 2 pictures. I do my 1 picture, and I kind of write it like this. I'm just going to write it one more time. If you don't want to, then that's okay. Your horizontal asymptote in rational form, that's found based on the degree. Are they the same degree? Remember, degree is the exponent. You're looking at the exponents first. Don't look at the coefficients unless they both have the same degree, same exponents. Then that's when you simplify the coefficients. So HA is in the front. Remember our y-intercept. Y-intercept is the constants at the end. And then think about where your factors go. That's going to be really important today when we're writing because we're going to be given these pieces of information. We have to put them in the right spot. If there's a hole in the graph, that factor goes top and bottom, numerator and denominator. Vertical asymptotes are leftover factors in the bottom. X-intercepts are leftover factors in the top. Okay? So honestly, these might be things that I'm like writing at the top of my test when I get it next week because this is really going to help you. There's a whole test on just identifying from equations, identifying from graphs, and then there's a whole test on writing, and when you write, you have to know where this stuff goes. Otherwise, it's not going to be good. Okay? So we need to have discussions as we go through these. Should we use transformational form or should we use rational form? Here's my hint for this. If it's talking transformations, stretched, reflected, shifted left, up and down, that needs to be in transformational form. If it's saying anything about holes in the graph, x-intercepts, y-intercepts, asymptotes, that's probably going to be rational form. You're going to see this form a whole lot more, okay? But we will, be able to assess you on both, so there you go. All right, number 1, a rational function has been vertically stretched by 3, shifted left 8, up 4. What form should we use? Transformational form because it's screaming transformations, okay?
Wait, how do you know screaming transformations?
It's giving you transformations. Vertical stretch, left 8, up 4. Okay, so make sure, guys, these are equations. If y'all don't put a y equals, I'm going to count off. Vertical stretch by 3, A, B, C, or D? A, so where does it go? Top, 3, over. Shifted left 8, A, B, C, or D? C, so it goes in the bottom with what sign?
Plus. Okay, it's shifted left is plus. Yes.
Left is the negative direction, but you got to switch a sign on C. So it's plus 8, up 4, A, B, C, or D? Okay. What does that tell you about? This is not part of the problem. This is the answer. That's all you need to do on this problem. But just for fun, what's your vertical asymptote here?
-8.
What's your horizontal asymptote? Okay, that's just extra bonus problem. Make sure you know how to do. No extra credit for that, but pat yourself on the back if you know how to do that. No, how about you will get test credit because you're going to have to be able to do that from that form. Okay? No, because you get to retest things to a 90. That is why. Well, then you better get 100, and that's maximum. So not everybody gets a trophy here, guys. Okay, all right, number 2. A rational function has a vertical asymptote at x equals 2, a horizontal asymptote at y equals -3, and an x-intercept at x equals -4. Should we do that in transformation form? No, this one we should do in rational form, okay? Because of that intercept, we need to do it in rational form. So as far as that goes, again, this is going to be y equals. I'm going to go ahead and set up a fraction bar and just think about where everything goes. Vertical asymptotes are factors where? In the bottom. So if my vertical asymptote is at x equals 2, I'm gonna put here D for denominator. Or is that gonna confuse y'all if we just did transformations? Should I put B for bottom? B for bottom. Okay. No, you have to write it as a factor. You have to write it as a factor, so it's gonna be x minus 2 in the denominator. Okay. Horizontal asymptote. Here's the thing with horizontal asymptotes. I kind of wait on these till the end, but let's talk about it. If it's y equals a number that is not 0, what case does it have to be? What's the only way to get HA equals a number that's not 0? Cocoa, okay? Make a note of that, and we're going to check that at the end. Okay? X-intercepts, though, those have a place. Those are factors where? At the top. So how would you write that as a factor?
3 over 1.
X plus 4. Okay, so this is T for top. Okay, so I'm going to kind of label where that stuff is going so you can know where that came from. Okay, then I need to make sure, am I going to be in the COCO case? Do I have the same degree in the top and the bottom right now? Okay, once you confirm that, now we can actually go in and plug in the -3. You can have more answers, but the easiest one, remember, they have to reduce to be -3. So you could do like -6 over 2 or -9 over 3. What's the easiest one to do? Just put a -3 in the front, okay? And I said, if you looked in the instructions, it said leave your answers in factored form. So this answer works, okay? So with the horizontal asymptote, that's usually something I consider the case. Does it need to be Coco, Bobo, or Botan? And then I kind of fix that at the very end. So keep that in mind as we move forward, okay? All right, try number 3. It is pretty easy. Think about where everything goes. If there's a hole in the graph, that's a dead giveaway. You're not writing in transformational form. You're going to do rational form there. Okay, so again, I'm kind of in the problem. I'm labeling a little bit like, where is this going to go? Bottom, because it's a vertical asymptote. If there's a hole, that factor has to go in both top and bottom. That was different. X-intercepts have to go in the top. What case do we have to be in because we have a HA at y equals 3? That has to be Coco. So if I put my factors in, am I going to be same degree on top and same degree on bottom? What's the degree on the top? 2. What's the degree on the bottom? 2. So I am in Coco case. So then I just need to pick 2 numbers that reduce to be what? 3. And again, I would just say put 3 over 1. That's easier, but you're good there. Are we okay with that? Pretty easy? I'm going to get a little bit more. Have to think here, but we're still good. Okay, go ahead and flip over. Let's talk about 4 real quick. I'm adding a piece of information on 4, okay? Why? Because I want to. Also, I'm telling you this is going to have a y-intercept at 0, -3 over 2. I really were going to cross my fingers that this works out because I think this should work, but we'll just roll with it. If it doesn't, then, that was a bust. But I did this on purpose. I think this is going to help us when we get to our graphs, but I want you to think right now where we are. What form should we write in? We should do rational form. So let's go ahead and start with that. Okay. Vertical asymptote. Where does that go? On the bottom. It's a factor. So let's put on the bottom x plus 3. Oh, there's 2. And x equals 2. Ah, so what else are we going to put at the bottom? X minus 2. Okay. So both of those. There's a hole in the graph. So where's that factor going to go? Top and bottom. So I'm going to put both. So I need to put a factor of x plus 4. X plus 4. Hey, do y'all have a question? No? Okay. X-intercept to 3. Where does the x-intercept go? Top. So I'm going to have a factor of x minus 3. Okay? All right. So here's what it says next. As x approaches infinity, y approaches 0. What is that telling you? That's your HA. Very good. Your HA is y equals 0. So what case is that? That's got to be bigger on bottom. So when you have, and we're going to talk about this like pretty extensively with graphs, if you have the case that it's bigger on bottom, that just means that the degree is bigger on bottom no matter what the coefficients are. But because we know a y-intercept, an additional point, we're going to have to figure out what exactly does that coefficient have to be. So there's going to be some more thinking with this, and you're going to have to do this with graphs. So just listen to what I'm about to say. Are we bigger on bottom right now just looking at my factors? What's the degree of the top? 2. What's the degree of the bottom? 3. So we are bigger on bottom, so I can put a check mark there. But not only do I just want you to be bigger on the bottom, I also want to make sure that your graph goes through this point. And it's convenient that it's a y-intercept, but technically it can be any point. So for this, we've got to find out what number exactly has to go right here in this box for that y-intercept to work out. Okay? And again, you're going to have to do this in graphing, and really where it's going to come up more is when your HA is y equals 0. So we're going to work backwards. If we are given any point, convenience, if it's the y-intercept because the x value is 0, we're going to take that point and we're going to plug it in. 0 for x. And what are we going to plug in for y? Negative 3 over 2. So here we go. We're going to do this to the side. We're going to use this point. And we're going to do some mental math. So negative 3 over 2 is my y value. We'll call this box, we'll call it A. That'll be our variable. So A times what's 0 minus 3. Do y'all need me to write that? I should probably write that. 0 minus 3, 0 plus 4, over 0 plus 3, times 0 minus 2, times 0 plus 4. Can y'all see what I'm doing? Okay, I'm going to have to work this way. Negative 3 over 2 is equal to, what is 0 minus 3? Negative 3. 0 plus 4 is? See why it's nice to use the y-intercept because the value is 0. So what's my numerator? 3 times 4 is negative 12a. I like to put a at the back because it just makes most sense for me when I'm solving. On the denominator, what are we really multiplying? 3 times negative 2 times, so what is that? Negative 24. Don't you just love that I chose a fraction? It's just so great, okay? All right, now we're going to solve for a. So let's first thing, well, okay, there's a couple ways you can do it. What do y'all want to do? Oh, I don't know what you mean by reduce or something. Oh, the 12 and the 24. Okay, we could do that. We can start with that. So let me go over here. So this will be negative 3 over 2 is equal to, how does that reduce? 1 over 2. Should be positive, right? A. Okay, that actually might be smarter if you don't have a calculator and think about that. So nice. Okay, now what? A is being divided by 2. How do you want to do it? Multiply everything by 2. So if I multiply by 2 over here, that's going to go away. Got to multiply by 2 over here. What's going to happen there? That goes away too. So what is A equal to? Negative 3. And so your final answer, you would have to have that negative 3 right there.
Yeah, but isn't that negative 3 over 1 for the HA?
Well, it's not cocoa. So no, that's it. So here's what's kind of weird is that it's a little bit confusing. If it is bigger on the bottom, no matter what coefficients you have, your horizontal asymptote is going to be 0. So it can really be like truly, if I didn't give y'all that point, and I want you to realize why I added this in. If I didn't give you that y-intercept, you could put any number that you choose in front, and it will do all of those other things. But the fact that I knew specifically it had to go through that y-intercept or any other point I chose to give you, I had to go make sure specifically what number is going to make that happen. So you're going to have to do that with graphing. So I want you to kind of get your brain used to it. But yeah, that's how it's done. Do 5. Real quick, do 5. And then 6 we'll talk through again there. Actually, try to do 5. Try to set up 6. We might need to talk about that, though. What form did you use? I already wrote it. But what did y'all use? Transformation form. This is giving you transformation form. So what'd you get? Y equals. What makes it vertically reflected? What makes something do a vertical reflection? A negative what? Negative A. Okay, hey, what is that also known as? Reflection over the what? If it's vertically reflected, it's reflection over the x-axis. Just make sure you know both, because I don't really know how it's going to be written, but you know both. Okay? So you need to have a negative at the top. Does it give us an actual number? No. Okay, so then really you could pick whatever number. Did y'all just do -1? That's probably what I would have done, but I mean, infinity's not a real number, but you could really pick any number that you want. Okay? Shifted right 3, what's the denominator? What's the denominator? X minus 3, down 6. Okay? All right, last one. Last writing from words. Okay? This one is one we kind of have to think about. So, what form? Hey. What form? What form? Rational form. Okay, here we go. Y equals has a hole in the graph. Where's that factor going to go? Matthew, where's the factor going to go? If there's a hole.
There's a whole second. It's on the top and bottom.
Okay, so I have, it doesn't really matter. X plus 3, X plus 3. Okay? Horizontal asymptote of Y equals 2. What case is that if it's Y equals a number? Cocoa. Okay, so hold off on that. Vertical asymptote of X equals 5. Where does that go? Bottom. What's the factor? X minus 5. And then your y-intercept is 0.8. Okay, your y-intercept doesn't have an actual factored form place. So this is the point that we're going to use again. Because, yeah, you can. 4 over 5 is fine. This is the point that we're going to use because what case do we need to be in? We need to be in, if it's cocoa, they have to be the what? Same degree. Are they the same degree right now? No, they're not the same degree. What's the degree on the top? 1. What's the degree on the bottom? 2. So this is not matching up for us to have an HA here. So we need another factor. Y'all, you should not be writing in X's anywhere unless it is one of these cases where it needs to be the same degree and it's not. So we need to figure out what does that number need to be so that we have another factor. So I'm going to do X minus, I'm going to pick a variable. What variable do we want to use? That's not a variable. How about R? A is fine. Oh, I usually use A at the beginning. I'm going to use R for root because whatever that factor is, it's going to be a root because it's an X. It's in the top, okay? But now, if I set that up, now I have to go solve for this. There's a box right here, okay? But now, when I find that, it will be cocoa. So what can I put in the very front now? A 2, okay? So does everyone kind of understand the idea? You need to make this cocoa. You need to have another factor up there, okay? So we need this. I'm going to make a note. Need another factor to be cocoa. Okay? Can y'all read that pink okay back there? Is it too bright? The pink marker?
So wait, don't we need to know what the specific coefficient would be because there's another place, right?
Well, since it's a reduction, it's not the coefficient that we need to solve for. We need to know what is that number in the factor need to be. Because whether or not I put I just know this needs to reduce to 2. So as long as I am doing 2 over 1 is going to be the easiest. But I think it's going to make sense in just a second. Okay, so we're going to use the point that they gave us, which happened to be a y-intercept. We're going to use that and work backwards. Okay, so what's the x value that we're going to plug in? Don't just say 21. What's the x value that we're going to plug in? 0. What's the y value that we're going to plug in? 0.8. Or if you want to do like Matthew, change that to 4/5. What do y'all want to do? Fraction or decimal? I don't think it matters. I think fractions are easier to do mental math. We'll do 4/5. We'll say that this is 4/5. 0.8, yeah. I don't like decimals and mental math. I don't like.
I don't like mental math either.
Okay, are we okay if I just go ahead and do the addition and not actually write 0 plus 3?
Yeah.
Okay, so what is 0 plus 3? 3. And then this one, I don't know, but it's going to be 0 minus r. So can I go ahead and do minus r for that? Yes. Again, I'm plugging in an x value of 0.
Wait, where did the 2 come from?
The same thing of it.
Yeah, where did the 2 come from?
The horizontal asymptote is 2. Okay.
2.
So I now have, let's clean this up. I have 4/5 is equal to, on the top, I've got 2 times 3 times a negative. -1. So 2 times 3 times -1 is, on the top, the way I said, I probably should have done x plus r, but it's okay. It'll work. On the bottom, I have 3 times -5 is -15. Can we reduce?
Yes.
Let's do that. 4/5 is equal to, okay, the 2 negatives reduce to be positives. How'd y'all reduce that? By 3?
12.
Yeah.
So A is equal to
2r over,
A is equal to 2.
right? And then again, the same thing can happen. You can times 5. Thank you. Times 5. And so you're solving 4 equals 2r. So what does r have to be? 2.
So does that mean that's plus 2 or minus 2?
You can put it in just as minus. So this now needs to be a 2. And then it should check out that if you were to figure out what the, like in this, we're not going to factor or FOIL this out, but 2 times 3 times -2 over 3 times -5, that should reduce to be positive 4/5. And it does need to be a minus because of the way
Is
we
that
said
like
it.
a way you can check your answer?
Yeah, yes, yes, okay. So you are going to have to be responsible for writing some of these in either form from words. The other thing you're going to be responsible for is writing from a graph. So let's take a quick brain break, and then we're going to talk about writing from a graph. This is the other part of writing. So on your test that's over graphing and writing, you're going to have to write from words like we just did a lot of, and then you're also going to have to write from graphs. It's really the same idea. Here's the thing that makes the graphs a little bit trickier. You have to go find the stuff. It's not just given to you. You have to actually find it. But guess what? On topic 1 of your test, you're going to be given a graph and have to find the stuff there. So it's like we're practicing all the skills. So if I look at number 7, I'm going to kind of make a list of what I want. I want to know vertical asymptotes for sure. I want to know horizontal asymptotes. And there will be one. We're not going to give you a case that's bigger on top. So you should have an HA. I want to check for x-intercepts. I want to check for holes in the graph. And really the only thing that you need from a hole in the graph is really just the x value. If you know a y-intercept, that's convenient. Otherwise, it could also just be like a random point. If the y-intercept, if you're not sure. So we're going to say y-intercept, and I'm going to put in parentheses, or good point. Good point. And that will help us check our HA at the end. Okay? Or good point. Or good point. Just roll with it, okay? Okay, so let's draw in. Do we know what our vertical asymptote is?
Oh, 3.
Draw it in. X equals 3.
Oh my gosh.
X equals 3. And again, you're going to have to identify this from a graph. That's part of your topic 1 test. There's only one. HA. What's the HA? It's also at 3. X-intercept. Is there an X-intercept?
Yes.
Ordered pair what? 2, 0. Hole in the graph.
Yes.
We really just need the x value because I don't really know what the y value is. But where is the x value? -4, and then that's really all we care about. I'm just going to put a question mark. You can guesstimate. I'm not going to.
So, like, if you, like, don't put it on the test, like, the y value, will you mark it off or not?
The questions that are asking you to, like, identify the parts, you would need to, but the graphs that we picked, if it's questionable, they have a point written down
Oh, okay.
for you to tell you what it is exactly. For a writing problem, this is just helping me write, so if you didn't put the y value, I wouldn't mark it wrong. And then the y-intercept, that's pretty good, right? That's at 2? 0, 2. Okay? All right, now we need to go through and we need to put it all together. So now it's kind of like the problem that you just did. Okay? You know everything. Now write the equation. Of course, we're going to write y equals. Where is the vertical asymptote going to go? What, top or bottom? Bottom. Okay? If the HA is y equals 3, what case is that in? That's Coco. I'm going to make a note about that. That's something I'm going to have to go check. X-intercept. Scoot back. X-intercept goes in the top. Hole in the graph goes both. And then the y-intercept is how I'm going to check. Move. Okay. All right. So vertical asymptote in the denominator. What factor do I have to put? X minus 3. Check. X-intercept goes in the numerator. What factor is that going to be? X minus 2. Check. Hole in the graph. Top and bottom. X plus 4. X plus 4. Check. Okay. Now, we need to make sure we're in Coco case. Okay, same degree. Are we going to be same degree? We have the right number of factors. So we shouldn't be adding in anything else with x's. We know our horizontal asymptote needs to reduce to 3, but I'm going to use the y-intercept just to confirm and make sure that there's going to be a 3 that goes right there. So the idea is to plug in 2 for y. 2 equals, again, I'm going to put this box right here. And then I'm going to plug in 0 for x. Okay? 0 minus 2 is -2. 0 plus 4 is 4. This is just confirmation, okay? Over 0 minus 3 is 0 plus 4 is. Okay? All right, clean this up. -2 times +4 is -8a. Over -3 times 4 is, again, you could reduce that, or I'm just going to multiply over the -12 because these numbers aren't too bad. And there's a whole number over here. What's 2 times -12 on this side? -24 equals -8a. Does a equals 3? Like I thought. So what needs to be in this box? And that checks our HA. So this is really more of like just confirmation to make sure that that goes in the right spot. Yes.
I simplified it to like 2 and 3.
That's fine.
But
When you multiply it over and then divide, it should be good. Yes.
but then 6. Okay.
Yeah.
Yeah, I did it right.
Hold on a second.
It already says that horizontal is so do we have to solve all of that just to prove it? Or can we just prove it?
This is for confirmation. In this case, technically, you do not have to go solve all of that, but there are cases when the HA is at 0 that you absolutely have to, and people forget every single year. So that's why I'm going to check it every single case. So that way you don't. But you are correct. If you know, if it's a number that's not 0, it should be that, but it's not bad to check. Okay?
What if it wasn't?
If it's a Bobo case, then you've got something wrong in there.
So if it is no, if it was like the number it is now, and you checked it, it wasn't just saying, does that mean it's
That would mean you either grabbed something from the graph wrong. Okay? All right, here we go. This one. This is a graph that, how many vertical asymptotes do you have?
Right, so ball two.
2. Sure. So you have to draw those in. There are 2 vertical asymptotes, so this would not be so fun to graph, but that's okay. Where are my vertical asymptotes at? -3, +2. Horizontal asymptote is at 2. Is there a hole in the graph? No. X-intercept. -4, 0, and 3, 0. Hole, I'm going to write none. Y-intercept. 0, 4. That's kind of my list, so I'm good to go there. What case does it need to be if it's y equals 2? If the HA is y equals 2? Has to be Cocoa. All right, put your factors in and make sure it's set up for Cocoa. And then I also would like you to check using your y-intercept to make sure that your coefficients are working out. Yes, ma'am.
On the test, do you want us to write like none for whole? Like if they don't give us a spot?
No, you don't have to. If it was one of the identifying ones, they probably would have a spot and you would write none. But no, if there's not one and you don't write it in your notes, then it's fine. It is something though that you want to always make sure you're checking for. And again, we know there should be a 2 in the front because that's our HA, but let's just confirm it with the y-intercept. And again, it's really nice to use the y-intercept because that x value is 0, and so it just makes your mental math life easier. I think the fourth problem, like there's the y-intercept, you're not for sure, so you have to use like a different point, but it's the same math-wise. It's just easier when it is when it's at 0. And it does check. Yay. All right, let's do one more. Let's do one more. Let's finish this, and then you can. Let's do number 9. I'll do number 9. We'll save number 10. We can do. How about we do number 10 as a warm up for next class? Deal? Okay. All right, go through our list. What do we need to find? Number 9, last problem. We'll do warm up, review day. We need to find the vertical asymptote, horizontal asymptote, x-intercept, whole, y-intercept. I don't know why this is the order, but that's just the way my brain's working today. Go ahead and identify that stuff. What's your horizontal asymptote on this? Good. y equals 0. Is there an x-intercept? No. None. Okay, so what's the case going to be if it's y equals 0? This is the one we've got to be so careful about. If it is bigger on bottom and the HA is at 0, you have to use this point to find A. Okay? So this isn't a checkpoint. This is going to help us find the A value, quote unquote, like that. Okay? I would star this. You've got to know how to do this math. Okay? All right, vertical asymptote, we know that's going to go in the bottom. There's no x-intercept, so we're not going to have a factor in the top. The whole, or for that, whole is going to go on both. All right, so let's set that up. On the bottom, I'm going to put a factor of x plus 4. Check. Also going to put a factor of on the bottom and the top. That checks the whole. Is it set up to where the degree is bigger on the bottom?
Yes.
Okay, so I'm going to be in this case. However, I have to figure out this A value right here. What number is not only going to make this bigger on the bottom, but it's going to make it go through the specific point, which happens to be a y-intercept because that point is nice and pretty. Okay? So that's where we have to use that to find that A value. And that's what we've been doing, so it shouldn't be really foreign to you. We've been using this as a check, but now it's more important. It's not just a check. It's what specifically does that have to be. Okay? So now we're going to do that right there. So the y value I'm plugging in is A. The x value I'm plugging in is 0. 0 plus 8 is over 0 plus 4. 0 plus 8. Okay. And we all understand that it doesn't have to be a y-intercept that you use to find this value, correct? Can be any point on the graph, but y-intercepts are always my first choice. But you may not always know that. So this is going to be 1 equals 8a over 32. I'm just, again, you can reduce. I'm just kind of in the mood to multiply instead of reducing, but it's all the same. So this is going to give me 32 equals 8a. 32 divided by 8 is... So I've got to go put this specific value here. And it's trickier when it's bigger on bottom case because you don't, Coco's nice. You know it has to reduce to be that number, okay? So it's more of a check. But bigger on bottom and goes through a specific point, you have to go do this step right here. All right? So we'll save 10 as a warm-up for review day. You've got some homework that's overriding. That's what you need to have done next class. We got to check for understanding overriding. Also next class. That's all I got.